In this video we're looking at voltage dividers, what they are, how they work, and some examples in real life. So first of all, it's quite useful to be able to take your voltage supply and to, say it's a 9 volt supply, and to divide that up and take a different voltage out than the supply gives you. So for instance, we might want to take out the voltage between here and 0 volts. It's always with reference to your negative or your 0 volt place. So you could think of it as, because this side on the right here is also connected round to the negative, so you could think of it as this voltage across the second resistor here. We'll call that R2 and R1. So as we know from Ohm's law, for the same current travelling around that circuit, there will be a larger voltage over a larger resistor. And it works out that if we compare the ratio of R1 to R2, so if R1 is twice as big as R2, for instance, that is the same ratio or equivalent to the voltage drop across 1 compared to the voltage drop across R2, and that voltage, it's our V out in this case up here. So let's give you a concrete example. If that's 10 ohms and that's 5 ohms, with R1 being 10 ohms, that's going to, we'll do it this way. There's different ways you can calculate it. I'm going to do it one way, but you should be able to get a sense of what's happening. 10 ohms out of the total 10 plus 5 times by the voltage supply, which in this case is 9 volts. Let's just write 9 because it's easier. 10 over 10 plus 5 is 2/3, so it's 2/3 of 9 is 6 volts. That means V out is going to be 3 volts. 3 volts, and that's 3 volts might be used for, say, running an LED or something like that, or running a small circuit that only allows 3 volts to do that, and you need consistent 3 volts. So we've sort of gone all over the place a little bit, but let's just come back to our main thing. What it is, a voltage divider divides up the supply voltage according to the ratio of resistances. And going back to our example down here, we had R1 was 10, R2 was 5. That means we've got a 2 to 1 ratio, and our voltages are 2 to 1 coming out, and that worked out right because it was 6 volts and 3 volts, which is still 2 to 1. Okay, so that's what it is. How it works, I guess we've answered that because it divides up the ratio according to the resistance, and yeah, it's to do with the proportion of the resistance. That's why it's a ratio. It's not to do with the size. So you could double both of these. So you can make this 20 ohms and this 10 ohms, and you would still have exactly the same ratio, exactly the same voltage drop across each. The only difference would be that if you're considering the total circuit voltage, total circuit current, total circuit resistance, this doesn't change. It's still the same. Your voltage is the same, but your resistance has increased. So for the voltage to remain the same, your current has to decrease, and that makes sense because you've increased the resistance, making it harder for electricity to flow, thereby decreasing the current. Yeah. So examples in real life. This is voltage divider is not just a random circuit that you would use for fun and learning physics kind of things, but it has a lot of uses. You can use a voltage divider for switching transistors. Here's a transistor circuit, a very simple circuit. Put a resistor in there, and then we've got our supply somewhere here. So it's a 9 volt supply again for keeping it nice and easy. We can have one resistor here. We can have a LDR here, light dependent resistor, that's supposed to be connected, and we can have an LED over here, and that's connected to the 0 volt. Okay, this is remember the electronic engineer's way of drawing diagrams. The 9V at the top is just the positive part of the battery, and the 0V at the bottom is the negative part. But in any case, if this was about 47k ohms, how this circuit works and uses its voltage divider, this resistor here is dependent upon the light, and the less light shining on it, the higher the resistance. Remember, the higher the resistance means the greater the voltage drop across it. As it gets dark enough over this resistor, reducing the amount of light, it increases the voltage drop between here and here. That will allow the transistor here to switch on, which passes current through it now, lighting up the LED. So this is a solar light, or a solar switching light. So like the ones you stick in your garden to turn them on, they turn on automatically at night time as the resistance in the variable resistor increases. The variable resistor from the light dependent varying according to the light resistor. Anyway, so that's one use. You can also change resistance according with temperature, use temperature to switch. That's very handy. The most common example that you probably will come across in books and things, because a lot of them aren't necessarily up to date, is using a variable resistor, a variable resistor, to adjust the voltage out. So the voltage is taken between here and here. And what this can, just to refresh your memory, when you move the slider to the top, you're effectively bypassing the resistor and having no voltage drop, or all voltage drop, depending on how you set it up. And down the very bottom, you're going through the entire resistor to do its thing. Okay, so you get different voltages according to the amount of resistance, and it's according to the ratio of how far you've shifted between the two parts of the variable resistor. It's a long coil of wire, and you're just changing the length of the wire and starting halfway in between or whatever. But anyway, how to use a variable resistor is a really quick circuit that many of you will have used before. This is an iPod, iPad, whatever, has a output for a signal, like an audio signal, positive and a negative. The negative goes down to ground, and the positive is going to go into a variable resistor. The variable resistor is also connected to ground down here, but we want to take that varying output and we're going to throw that into an amplifier. Okay, amplifier also has a negative which goes down to ground. All these ground ones are connected, all the negatives are connected, it's nice and easy. But your amplifier is also connected to a speaker, which cranks a lot of sound with the negative connected to there. See all these positives, how they're going. Okay, so you're using a variable resistor to adjust how much of your iPod signal is going in. Here's your signal, and if your variable resistor is all the way at the top, you're getting 100%. So that's going to be maximum volume that's being amplified. Okay, if you're right down the bottom, you're feeding in 0 volts because it's ground. So you would get 0% of the volume. So you've got no volume coming through. And somewhere in the middle is somewhere in the middle, ranging from 100 down to 0%. So voltage divider, very, very useful, and I think we've covered it to death right there.